So yesterday we worked hard on bar graphs, double bar graphs, and even some pictographs. Today our learning target is you are going to create and interpret line graphs, and you're going to use some ordered pairs to do that. You all know what ordered pairs are. You know what coordinates are, so that's going to help you. How can this kind of data be represented? How can we show this? Well, there's one really important thing about line graphs that everybody has to remember. The only time we use a line graph is when we see a change over time. When something changes over time is the only time we ever use line graphs. Now that time could be minutes, it could be hours, it could be days, months, years, whatever. So here's some information on this house plant that I have growing at my house. And when I planted it, day 1, it grew to this height. Day 3 to this, day 5 to 10, and so forth. So this table shows our growth over several days. This data could be displayed in a line graph. A line graph is often used to show a trend. Now a trend is basically the general direction of your line. Trends can go up or increase. Trends can go down or decrease. Or trends can be very irregular. They can also be steady. How do we know that we should use a line graph with this data? Well, because this information has time. It has days, so we know that that's the graph that we would choose. Can you think of some other real-life situations where we might be able to graph a change over time? Aiden? Okay, very similar to this then. How about something different? I like that example. Gas used in a vehicle over time. Kaden? Money. Money earned. How tall you got. Could we graph your height or your weight from birth every year on your birthday? Sure. Your age. Well, unfortunately, I think something has to go along with age because obviously everybody gets 1 year older on every birthday. There's no give or take to that. I wish I could go backwards now. You probably wish you could jump ahead. True. Okay. So now that we've talked about some other examples, they said some examples they thought of were how tall you grow each year, the dollar amount of movie tickets for sale each day of the week. So if the Pipestone Theater were open, how much money they took in on Monday and Tuesday and Wednesday and Thursday. You would probably see a trend. My guess is that movie theaters probably make more on the weekends than they do during the week. Would you agree? Yeah. Mm-hmm. Outside temperature throughout the day. We could certainly do that as well. What are some units of time other than the day that you think we could put in a line graph? Decades, sure. Okay, like specific time of the day. I like that one. Centuries. Let's think a little smaller. Seconds. Minutes. I don't know about that. Here are some examples, all the ones that you mentioned. Look at the data in the table for houseplants. Let's think about how we would put this on a coordinate grid, okay? So here's our coordinate grid, like what we worked on last week. So we know that what coordinates go in the bottom left corner right here? What do we put there? Emma, a 0. What do we call that 0? Starts with an O. The origin. The origin, yeah, that's right. The origin, or 0, 0, is where we start. Now, what unit is labeled on the x-axis? That's the one down here. Which of these? Would we put days or would we put height? Sarah? We are. We're going to put our information in time on the x-axis. Okay, so there we go. Now, the smallest number was 1. The largest number was 9, so they went in intervals of just 1. Could have they gone in intervals of 2?
No.
Well, they could have, but then they would have gone all the way up to 20. And we'd have a lot of empty space because there's no numbers in this column that are close to that. Okay, so obviously on the y-axis we're going to put height. Our smallest number is 4, our largest number is 14. What would be good intervals over there? Aaron? By 2s? That's what they did. Now notice they labeled each. These are the days. This is the height in centimeters. So now all we have to do is take this information and plot it. Who's willing to do that for me? Well, I want you to use the red, starting with day 1. Plot those 5 pieces of information, those 5 ordered pairs. 1, oh, yep, there you go. Yeah, you know what? We may need to do a little orienting after this lesson. Doesn't have to be perfect. That's totally fine. Now today, as he's plotting the rest of this, it's going to be different than last week. Last week you made a perfectly straight line when you were graphing linear equations. Today your line may not be perfectly straight. You'll need to use a straight edge to connect them. If you would connect them when you're done, that would be great for us. Thank you, Will. Now do your best to connect. Doesn't have to be perfect. Okay, so when you look at this graph, 5th graders, what's the trend that you see? Alexis? Which is, what's another word for going up? Increasing. There you go. So our trend is that the height increases each day. That's our trend. Why would it be important that our x-axis show equal amounts of increase? Why couldn't we go 1, 3, 9, 15, 16? Why couldn't we just have random numbers that are in our information? That's right. If you don't number it evenly, your graph is not going to turn out. You're not going to see the change that you need to. You have to have perfect intervals, whether it's by 1s, 2s, 5s, 10s, whatever it may be. Does the y-axis have to be labeled with the same numbers as the x-axis? No. In this case, we numbered by 1s. In this case, we numbered by 2s. All right. Remember, when we're plotting ordered pairs, we're going over up. Do you notice how if we would have made this information into a bar graph, it wouldn't have shown us the change over time? Would it? No, it certainly wouldn't have. It would have looked way different. Okay, so I need some helpers. Now I took this information right here and I copied it over there because we're going to make ourselves a graph that looks just like this. So Sam, we're using you. This is your reading log. So he read 2 minutes on the first day, 4 pages he got. 4 minutes, 6 pages, and so forth. Okay, keep in mind this is made ahead of time. Who is willing to fix this up for me? Well, his hand isn't up, so I'm not going to make him come up, Will. All right, I need the first person to come up. You need to label our x-axis, our y-axis, and the title. That's all I want you to do. So who's willing to do that? I need somebody. Caden, you want to come up? You're taller. Okay. We'll click back so that you can take a quick peek again. That's right. What are you going to do for the title? Yep. Okay, so Caden is titling it. She just said she's going to title it Sam's Reading Log. Okay, now down here, What are we going to label the x-axis? Should we look back and see? What do you think? Minutes or pages? Help Kaden out. Along the x-axis, do we want our time or do we want our other information? We always want our time along the bottom, don't we? So, which one? Minutes or pages? Yep. Number of minutes. Good enough. Perfect. Now our y-axis should be labeled. Yep. She's labeling our y-axis pages red. This is your job, America. Got it? Okay, now you can hand that to somebody who wants to come up and plot those ordered pairs for me. Okay, Cole. I copied the information onto my board so we don't have to continue to look back. Yep, you're right. Now, he's going to connect these dots, and as he's doing that, I want you to tell me what overall trend is happening.
It's increasing.
And then it evens out, doesn't it? Why? What could be a reason? Thank you, Cole. What could be a reason why it evened out? Why the first time he read for 6 minutes did he go 10 pages, and then he read for 8 minutes and he still read only 10 pages? Well, what could be a reason behind that? This is an opinion question, so I want to hear your opinion. Aaron P? Maybe he had a sibling come in and bug him, so that's a possibility. Hey, we all know that's a possibility. Aiden, what do you think?
He used so many words on one page.
Like what kind of words?
He must be in a chapter book, like a big one.
Well, that's possible. Maybe the words on the pages that he read the first time and the second time were very different. Maybe they were harder words. Cole?
Maybe he had the book somewhere.
Maybe, but then he wouldn't be counting his... You really can't count your minutes if you're not reading, if you're out of the room, right?
You were reading and then you had to stop and then go.
Then they probably wouldn't keep counting the time, right? The mailman came. Okay. All right. All right, let's take a look at some line graphs and try to answer some questions regarding them. The first one. How many degrees hotter was it on Wednesday than Thursday? Okay. 10, 20, 30, 40. Okay. Wednesday is here. Thursday is here. Little tricky, Darius. What do you think?
I think C.
20. Tell me why. How many was Wednesday? About, and Thursday was about 35 minus 15 is 20 degrees. Alexis, use this line graph. How much more in dollars is the cost for 5 months than 4 months? Here's 5 months. Here's 4 months. How much more is 5 months than 4 months? $25 more. What did you do? When it says to get from here to here, you took 25 away. Well, we're finding the difference, right? When we ask for how much more, that means subtract. So that's what you did. 125 minus 100. You could do that one in your head, right? Susan started babysitting when she was 11, and now she's 16. The following line graph shows how much she earned per hour during these years. How much did she earn when she was 15 years old?